Yes, hope all of us are doing great. My name is Ernest, and this is Ernest Sciences and Mathematics TV channel. In our discussion today, I'm going to look at the concept of electric field lines, and this is going to assist us in trying to, of course, identify some of the rules and procedure which we need to follow in order to represent this specific concept of field lines. And this, of course, are going to be electric field lines, which are going to be providing for us a convenient graphical representation of electric fields in space, as we mentioned. And of course, we are going to mention some of the rules which we need to abide by in order for us to, of course, represent these lines effectively. Now, in this particular case, I'm going to consider the concept of the two charges which we had mentioned. Now, I've given an example of a positive charge and a negative charge given as such. And we have decided that these specific charges are going to be having what we call electric field lines. And therefore, they are going to have a field whereby these lines representing these specific electric fields in space are going to be indicated using a such, and the fields are going to be, of course, originating from the positive, and therefore we're going to expect them to be having arrows indicating this specific direction on the negative charge respectively. Now, this was our last representation for these specific lines, and in case we have two particles which are interacting, which are referred to as a dipole, and therefore we can consider the case of an illustration for a pair of charges with equal magnitude but opposite direction, like the ones which I've listed, which are going to be having field lines shown as above. So we're going to have a positive charge there and a negative one. So the forces of attraction which are going to be experienced from these ones are going to be shown using those specific lines as I've indicated. And we can, of course, do a continuation of these specific lines. And therefore, I'm going to illustrate on what basically these specific concepts are going to imply. So in this case, we're going to have these specific lines going towards that negative charge particle. And then we're going to have other lines going in this specific direction as such. So we shall have these ones, and I'm going to indicate using those specific arrows. Now, in case we can just do addition once, we can have these ones indicated as such, and they're going to be having the arrows moving towards that specific direction as such. So these are going to be the field lines which are going to represent what we call an electric dipole. And the pattern of these specific lines can be obtained by considering a number of course, considerations which we had mentioned. And this, of course, is going to be the concept of what we refer to as symmetry. But from my previous statement, I had mentioned that basically these field lines are going to be radiating outwards from the positive charge as I've mentioned, and of course inwards towards the negative charge as indicated from this specific illustration below. Now we can have these specific patterns by doing some considerations which I've mentioned, and this, of course, are going to be the concept of symmetry, which we are going to elaborate on shortly. Now, in this case, symmetry refers to basically the concept of trying to have an equal kind of representation for each of the sets, whereby we are going to have for every point above the line which is going to be emanating from the positive charge, there's going to be an equivalent point on the lower side of this specific line, and therefore this specific pattern is going to be maintained, whereby we're going to have a concept of symmetry for the lines which are going to be joining these specific points of the dipole for the positive and negative charge respectively. And this is going to be one of the procedures that we're going to use in order to illustrate the concept of field lines, by trying to abide ourselves with this specific aspect of symmetry. Then therefore we are going also to look at the concept of the near field and in that specific respect the aspect of a far field given as such. Now, as we have said, these specific points are going to be radial, whereby they are going to be originating from this specific charge and terminating this one. But as we are going to see, if we try to consider the concentration of, perhaps I can just give you using this particular illustration by putting additional lines. So we're going to have these charges given as such, and then we shall have these ones given as such, emanating from that one given as such. So if we try to consider these specific lines at a particular point and near this specific charge, we're going to see that for the near field lines, or very close to the charges, the field lines due to the charges are going to be predominating. And then we're going to see that the lines are going to be radial, as we have said. And for the far field, we're going to see that for the system, this specific kind of a system of charges, the patterns are going to look like that one of a point charge, which basically are listed whenever we're going to talk about the concept of a field lines or a charged particle. Now, in this specific case, that one basically refers to the concept of predomination of these specific lines near the charge, and of course, as they radiate out, the aspect of them having a larger influence is going to be diminished. Now, the last one we're going to look at this specific point is the concept of a null point. And as we can see, there's going to be some spaces in between these particular lines, which are going to be consisting no lines of field lines, electrical field lines. These specific points, the electric, of course, which field which we can indicate with this one, I've just given as a magnitude of 0. And therefore, we are going to expect that at a point at which this one is equivalent to 0, there are not going to be field lines that are going to pass at this particular point, and that's going to be another consideration which we are going to look at. Now, that one is going to give us, in essence, some of the properties which have basically been listing in terms of these specific characteristics, whereby we are going to see that the direction of the field lines, of course, the direction of the electric field vector at these specific field lines is going to be tangent to the field lines. Perhaps that one I can just give it using an illustration later. But we're going to see that the direction of this electric field vector E, which I've given. So I've indicated this one as such. So therefore, this is going to be a vector quantity. And therefore, we are saying that the direction of the electric field vector E at this specific point is going to be tangent to the electrical field, which means we are going to expect if the electric field is moving in this specific direction, then therefore we're going to have this specific field vector being tangent or at a right angle with this specific field lines such. Now, the number of field lines, of course, per unit area, which is a concentration to a surface perpendicular to the lines, is going to be, of course, proportional to the magnitude of electric field in a given region. And that one can be given in terms of a formula for easier elaboration for that one. And I'm going to do it in our next discussion from this. Now, I mentioned basically that these particular field lines are going to begin from a positive charge and terminate at the negative charge, or they're going to begin from the positive charge or infinity and terminate on the negative charge or infinity, as we are going to be illustrating them in our subsequent discussions. And of course, we're going to see that there's an aspect of proportionality which I've mentioned concerning of course, the number of field lines and of course, the magnitude of the charge, which are going to be proportional in that specific field. And lastly, we're going to see that these particular field lines are not going to cross one another, and therefore they're not going to be intersecting at another point. So therefore, we are going to take that one into consideration in case we are going to represent them in our subsequent discussions. And that basically is going to be a summary of the concept of electric field lines. And that's going to assist us supplement on the previous videos we have discussed on various aspects of these particular charges. So check our description boxes for various links of other videos, and kindly subscribe and engage us in the comment section, and also ring that notification bell to be getting updates on our various uploads we do in mathematics and sciences. So that is it for now, guys. Bye, God bless you. Catch us in our next video.